Today we are going to show you nom, a parser for Rust, and we will parse the Redis protocol commands with nom. So Luciano prepared some awesome slides about nom, and I think we will start from those ones, correct?
Yeah, let's try to do that. At least we want to try to give you a brief overview of what nom looks like, because nom, I think, is an amazing library, but it takes a little bit to click, and hopefully we'll be able to, with those slides, to give you a quick introduction that should demystify the kind of the mindset that you need to have. Okay, so let's get started. Okay, so what is a parser? Basically, the simplest definition that I could think of, I don't know if it's a very academic definition, but it's basically a program that can take text or bytes and turn it into some kind of structured information. And if you want to have an example, we can imagine that, I don't know, maybe we have a 3D file that lists a bunch of points. And if we want to parse that file, maybe at some point we find a line like this and we need to figure out how to read that line and convert it into an actual object in memory that we can use in our software. So basically, that definition might look like something like this in Rust. But effectively, we need to extrapolate from text 3 integers and store them somewhere in our program. So one very naive approach that I'm sure you have done many times, I personally have done it almost all the time. It is crap, but it does the job most of the time, is when you start to use string splitting like crazy. So in this particular case, we might have the input string that looks like this. And this is a bit of a pseudo language. It's not really Rust or Python or JavaScript or nothing else. So don't worry too much about the syntax. But the idea is that you can say, okay, I'm going to split on the column and I'm going to keep only 2 parts. So I'm going to have point on the left side and on the right side, everything else. So column and space are going to be the delimiter. So we're separating left and right. We call left the label and we call right the remainder of the string. At this point, we need to get rid of the parentheses. So what can we do? We can split on the first parenthesis and take only the right side. Then we can split on the second parenthesis, the closing one, and take only the left side. At this point, we only have numbers, and you can imagine that we might have another split with the space, so common space, and then we take the 3 values that come out of that. At that point, depending on the language, you can do like a parse int or whatever, but convert that string to a number.
Your
Like
language only has a split. You don't have trim or
exact.
stripe.
Super simple. Yeah, I guess, yeah, in reality, you could also use stream, you can use substring, depending on what do you know about the string, how much can it change, and you can be smart and figure out how to slice that string effectively. Now, this works, but there are some caveats. The first one is that this approach is not always suitable. Like, you need to have good delimiters, I would say, which is not necessarily always the case, right? Sometimes you need to, I don't know, certain protocols will tell you from now on there are 5 bytes and you need to figure out how to read that 5, and then based on that 5 you need to read the following 5 bytes to extrapolate some information. So depending on the protocol, this approach might be a little bit trickier to implement. It is simple for simple stuff, but the more complex the protocol, the more variability there is in the protocol, the more challenging it becomes to handle all the cases correctly. And then if you need to report errors, for instance, what happens if your string is not formatted by the standard, right? You need to be able to deal with that and report an error correctly, which is not always going to be easy when you use this approach. So there is another idea, which is the one that is implemented by nom, that, again, I don't know if this is the most academic definition, but I'm going to call it consuming parser, because they implement this idea where they try to eat and match the source text or a source of bytes. And then it's a sequence of steps where at every step you are trying to eat some particular type of information. If it matches, then you continue. If it doesn't match, you can stop and raise an exception. So you are always consuming. Sorry, go ahead.
Yeah. Can I just point out that there is something in the middle between the med split and this one, that is parsing with regex?
Oh yeah, that's a good one I didn't mention. Yeah.
And but remember that when you have a problem and you use regex, you have two problems then. So
Use it with cautious. Yeah.
yeah, exactly.
Okay, so I suppose consuming parsers are maybe a better idea, maybe a better approach, especially when you want to build something a little bit more robust. So the idea might look like this. You have again the same string as an input. So the first step, and again, this is kind of a pseudo language. Imagine you have specific functions that implement some kind of logic to consume the string for a bit until it matches a certain expectation. For instance, here read label might look for alphanumeric characters, right? So it's going to consume as long as it finds alphanumeric characters. As soon as it finds something else, it's going to stop there. So making that assumption, when you call read label, what happens is that it's going to consume as much as it can. So it's going to extract point, and then there will be like a reminder of the string. So generally what you consumed is the parse data, and then you have the reminder. So this is generally the output of this kind of parsers. They always read a little bit, extrapolate some information, and they will return whatever was extrapolated plus whatever else is remaining in the string. So the next step could be, okay, now read the separator. We know there is going to be a column with a space. So we might have some logic that, for instance, look for the column. Now that you parsed a label correctly, you need to see that there is a column. And when you do that, the value that you are parsing is the column. Whatever is the reminder is the space, parentheses, and the three numbers. You can keep going that way, and you can say, okay, read spaces. Maybe the protocol actually says that you can have an arbitrary number of spaces there. It might be 0, it might be 1, it might be, I don't know, 10, whatever. Maybe you can format the data in a way that is aligned. So you could be able to parse 0 on multiple spaces there. In this case, we have only one. So the data that is parsed is one space. The remainder is parentheses and the number. And you can keep going that way. And you might also have more higher level parsers. For instance, you might create your own sub parsers. You can say, okay, I can recognize a tuple of integers. So maybe I already have a parser for that, which is going to recognize this syntax with parentheses, sequence of numbers separated by comma. So you just call that parser, and it's going to extract the values for you already nicely formatted in an array of integers. And at that point, the remainder is empty, and you just finished the parsing. Now, how do you handle errors? Again, the idea is that if you have something and you try to match, if you have an input string like hello world and you try to say, okay, read a number, it's going to try to match that, but the first thing that it finds is not a number. So it's just going to fail and say, sorry, I cannot match a number on the input string, which is hello world. So at every step, you can consistently fail when you are not able to match whatever is that you are trying to parse. Okay, now this is kind of the generic context. Now let's see the specific of how nom implements this idea. So you can install nom with cargo add nom. And at this point, let's just jump back. Let's just jump straight into the code. So again, same example is our S, our input string. What you can do, let's assume that you have already implemented a parser in nom. The idea is that you will call parse point, for example. You pass the string, and then it's going to give you back a result. This result is going to tell you whether you were able to parse correctly, so if you actually got a point, or if there was an error. The interesting thing is that it gives you a little bit more than just a point. It gives you, here we are ignoring because we have an underscore, but if we matched a point and then there was more stuff in the string, it will give you whatever was the leftover and the point that you were able to parse. So you can imagine that you could call sequence of parsers and consume things your own way. Maybe you know that there is a point, then there is a line, then there is a square. You can call different parsers like parse point, parse line, parse square. So this is how nom makes the parsers composable. Okay, I think we have a question in the chat. It's actually more of a comment. Love nom used for day 2 of Advent of Code. with game. Yeah, we also use it a lot for Advent of Code. So if you look at our
Yeah.
repository for Advent of Code, there are lots of examples. But yeah, it's really cool.
Yes. But often I go back to regex.
Yeah. Sometimes the problem is simple enough that
Yes, yes.
I think we just wanted to use nom because it's cool and it's good to get a little bit of practice and learn the combinators. But for Advent of Code, most of the time you don't necessarily need
Yeah,
the
it's
power of
it's
nom.
absolutely overkill.
Okay, so yeah, we already explained all of that. So at this point, we should be able to parse an object and just print it. Now, how do we write that function parse point? That's the tricky bit, right?
How do
Okay.
you do? How do you do that?
Okay, so let's start with almost an empty function. The only thing we have here is the signature. So this function accept a string, our input, string slice, and it return a result. And this is a bit of a special result. Result which comes from nom, so it's like their own wrapper type over the regular result. And the reason why they do that is because nom can give you back two things, as we said. One is the input type. So basically, if you are parsing string slices, whatever is the remainder is still going to be a string slice. So it's the input type that captures both the input and whatever is the remainder that you are returning. And the other one is what is the specific output of your parser function. This particular function parses points. So we might have a struct called point3d. So we need to tell in the signature of the function, well, with this function, you can parse strings and return points. Now, the first step. The first step is basically we try to figure out if the string starts exactly with point, column, space. You might implement this slightly differently, but right now we are making it as simple as possible. And what's happening here? So tag is a special function that nom provides. These are generally called nom combinators. And the idea of tag is that it's going to try to do an exact match of whatever is the input with the string you are giving. Of course, it's not going to match the entire string. It's just going to say, is this string starting with this value? And if it does, so this is the value that we want to match, and this is the what we want to match against. So our input does start with point, column, space. If it does start with that, which is not guaranteed, so we need to raise errors when this is not the case. Maybe the string starts with square, right? At that point, this is just going to fail and return an error. So we can just propagate the error by using the question mark operator. But what do we get back in the case that everything is good? We get two things. The parsed value, in this case, is just going to be point, column, and space, which is something that we don't really care about, so we are just going to ignore. And then the input, which is the remainder of the string. So in our case, it's going to be parentheses, number, comma, another number, comma, another number, close parentheses. Okay, next step. So we already learned how to match specifically a chunk of the string. We can repeat the same step and just parse the opening parentheses. So again, we expect an opening parenthesis. If it's not there, we fail. If it's there, we receive the open parenthesis and the remainder of the string. We ignore the open parenthesis because it's not useful information that we need to retain. Next step is we can use this other function called i32, which is another combinator that nom gives you, which can consume as many numbers, like as many digits as possible. And then once all the digits are consumed, as soon as it finds something that is not a digit, it's going to stop and it's going to automatically try to cast that sequence of digits into a positive or negative number. Actually, it's going to even check if there is a sign. So you might have either a plus or a minus, and it's going to use that information to give you a positive or a negative number. And of course, the sign is optional. If it's not there, it's going to assume it's positive. So this is pretty cool that noms gives you all this library of combinators you can use to consume the input and do some kind of pre-built parsing. Now, at this point, what do we get back? The first coordinate, because this is the first number we are parsing, and the remainder of the input. At this point, we have everything we know to complete the parsing because we know there is going to be a comma, so we can use a tag, comma, and a space. there's going to be another number, and this is y, then again another comma and a space, then another number, and this is the z coordinate, and finally there's going to be a closing parenthesis. At that point, we extrapolated x, y, and z into specific variables, and we can construct a point 3D and return our result.
In the chat are asking if GNOME with iter2 also supports exponential representation, or if you need to use a float for that.
That's a good question. I know for sure that with the float, there is an equivalent float parser. That one supports the exponential representation. The I32, I honestly don't know. I think it's worth checking the documentation for
Also
that.
because with an iter2 you don't go very exponential. I mean, the game ends very early. You can't do E20 with an
Mhm.
iter2, it's too small.
Also, we have another comment by Beer Witcher. Yeah, performance were 6x slower with regex, I guess, compared to GNOME. And just one note there, be careful if you are recreating the same regex in a loop, which is a mistake we have done in our advent of code in the past.
Sometimes.
Of course, that's going to be even slower because the process of going from a string regex to a state machine that represents the regex is not cheap. So if you're doing it continuously in a loop, it's going to be even more obvious that there is a disconnect between the
Yeah.
performance of GNOME and the performance of a regex.
In Python also the same, compile it. You can use it in line in find all, but that is going to be slower than if you compile it at the beginning of the program and then you just use it. And yeah, the same in all languages, even in Go. So yeah.
Mm-hmm. Okay, so next up is our parser here works, but is a little bit dummy and ugly, right? And
What
it's not
happens if I remove a space?
exact, and it's not very reusable as well, right? For instance, you might want to keep the three numbers, or I have some kind of parser that can parse a sequence of numbers, right? You might split the task of parsing down to smaller parsers and then combine them together. So I'm going to give you another example, which is not necessarily a great implementation of this parser, but it should give you the idea of how you can build more composable parsers. For instance, we might create a parser that is only dedicated to do separators, right? Separators of values with the comma and a number of spaces. So again, this is the same signature. So we have an input value, we return an I result. The I result takes the same type of input. And in this case, we don't return anything because the separator in itself doesn't really have a value. So we can just return the unit type, which is kind of a null in a way. But what we are going to make sure is like an assertion that at that point in time, when you use this parser, actually there was a comma and a number of spaces, 0 or more spaces. One interesting thing here is that I'm using another combinator called pair. And pair, what allows you to do is just to stick together two different parsers and say, I'm going to try the first one and then the second one. They both need to match. So the first one is going to consume the comma. The second one is going to consume 0 or more spaces in sequence. And then what you get back is a tuple containing the result of the first parser and the result of the second parser. In this case, again, we don't care about both values because we know the first one is going to be a comma, the second one is going to be a string with 0 or more spaces. So we just discard them and we return the unit type. But if it doesn't match either one of the two, it's going to fail the entire parsing. Now, the next step is a little bit more complicated. This is the idea that you can parse a sequence of 3 coordinates. So for instance, 22, 17, minus 11. Here, what I'm doing, I'm using another combinator called tuple, which is very similar to pair, the one we saw before. But tuple allows you to have an arbitrary number of parsers that you are sticking together. And then what it returns is a tuple of all the values that are parsed. If at any stage you fail, everything is going to fail. So here, what is the return value is x, which is the first value I32 that we are parsing there. Then we put a separator. So we don't really care about the return of the separator because we know it's a unit type. So we use the underscore, then y, then another separator, then z. So this is literally half of the parser we need. And notice also how we are reusing the separator we created before. So this is where you start to see how composable things are when you start to break down the parsing into smaller units. Then you can easily reuse them into higher level parsers. Okay, moving on. How do you implement now parse point version 2? Initially, we can have a tag. Again, this is not very sophisticated. In reality, you might have different kinds of structures. Maybe point is just one of the many supported. We will probably see some examples in a bit, but maybe you can also have a square. So a more involved parser might just parse for different things. And then depending if you see a point or a square, it might invoke different following parsers to specifically parse that particular structure. Then here we are using delimited, which is another convenience that NOM gives us, which is going to say very often when you do a parser, you might have values or parts of your context that are wrapped by specific things. For instance, in this case, we have parentheses, an opening parenthesis and a closing parenthesis. So with delimited, is going to make your life a little bit easier because it's going to just check that the delimiters match before your actual parser, and it's going to discard their value. Like, you don't care about the delimiters, you just want to make sure that the delimiters are there. So at this point we can say, okay, I want to parse coordinates, but these coordinates need to be delimited by an opening parenthesis and a closing parenthesis, and the value that you get back is only the value of the parser that you are putting in between, which in our case is parse coordinates, which gives us 3 points in a tuple. So this is literally all our parser, and it looks a little bit nicer than the previous version that we wrote, and it reuses sub-parsers that we wrote as well. And when you write sub-parsers, they are easier to test, they are easier to combine, and in general, it is a little bit easier to read what they do. Any questions so far?
Not on the chat, and yeah, just we still have spaces that could be optional.
Mm-hmm.
Yeah,
Yeah, we could have
you addressed the optional space between comma with the space 0, correct? In the previous
yes.
function. Okay, but the space after the tag point is still not handled here. So,
Or for instance, the space between parentheses, right? You might have an opening parenthesis with.
in parentheses a
Yeah.
space and then the first number through.
So
Okay.
yeah, I said that this is not the most amazing implementation, but hopefully gives you the ideas of the capabilities that you get with NOM.
So here we could have, or we could have a generic parser that does the first inline 2 and finds out if it is a square, a point, or whatever else. Then with a match or with an if, you go through different way of parsing what's left of the string. Or is better to have a specific parser for specific type of objects and then let NOM try them? Do you have an idea if it's faster?
It's a good question. There is a combinator called OPT that allows you to check, for instance, for optional stuff. So it's gonna try something. If it's not matching, it's not gonna fail. It's just gonna continue with the next parser in the chain. Another one is called ALT, like I guess alternatives or whatever, where you can specify a tuple of parsers, and it's gonna try all of them in order. And the first one that matches is the one that wins.
Goes on.
But if none of them matches, then you have an error. That's kind of the case where you might have, I don't know, maybe you could have 3 different kinds of lines. You can have points, squares, I don't know, line, segment, whatever. And you can create 3 different parsers. They can come in any order, and you can use an alt to just see, okay, try all of them, and it needs to match one of them. And depending whichever matches, you get back an object.
And it goes in order. So the first one that matches the one that we will use, even if then having matched that one, the remainder of the string is going to error later on.
Yes.
Because I tried to implement NOM in Python, and I had that when there was an alt to implement, you could have taken sometimes 2 different routes. And if you were taking one, then it was possible to fail later instead of, I mean, sometimes you had these conditions where you were in a little bit ambiguous situation.
Yeah. Yeah, I guess that depends on the syntax of what you're trying to
Yes,
parse for
depends what you're
one,
trying to parse.
and
Yes,
then how you split your sub parsers, right?
yes. Cool. Thank you
Oh,
for the answer.
okay, I have a bunch of links here, and again, you can also get the slides if you want to easily access all the links. But I'm gonna quickly let's see, how do I exit full screen? There. I'm gonna quickly show you this one because this one is gonna be very useful to us in a second when we move on to the next exercise, which is gonna be a little bit trickier. So this is kind of a cheat sheet that GNOME gives you in their own official repository with kind of a summary of all the most common combinators. It's not extensive. There is even more than what you see here, but they try to group them in a way that makes sense. For instance, I don't know, you want to parse a single character, use this one. Or you want to make sure that the following characters is one of these ones. Uh, and you can see that they are grouped this way. So this is a very easy way to see if you're looking for a specific capability, what's the name of the function, what does it expect, a quick example on how to use it. So this page is really useful when you're writing a parser. And honestly, it takes a while to get used to all the different combinators, remember how they are called and how to combine them. So this is definitely a good resource to use the first time that you are starting to use GNOME. And very similarly, this is actually a little bit more advanced. Sometimes you write parsers that are a little bit more lower level. So how to handle errors, it's actually something that I still stumble on a little bit, and I always find a little bit tricky to report custom errors. But in this page, you have a bunch of examples on how to do that if you end up in a situation where you are actually writing a parser, like a new combinator from scratch, and you need to figure out, okay, if it fails, what is the best way to report an error? And there are different kinds of errors that might entirely panic GNOME, or that they might tell you, well, it's fine to roll back and maybe let another combinator try again. For instance, in the case where you have a sequence of combinators
Yeah.
or an optional combinator. So that there is a lot of sophistication there on how you might handle the life cycle of parsers. But yeah, I think this is where it starts to get a little bit deeper, and it's probably only if you're doing something very custom. And then the last one I have is the official examples. Also in the repository, they have like a JSON parser. Actually, they have like 3 different versions. So you can, if you need more advanced inspirations, you can look there. And finally, the documentation here, which gives you all the different methods, structs with examples and so on.
Now we are
Oh,
jumping to what?
we have an amazing question, which is where the name comes from. And
No idea.
I think if we go to the README, it's quite clear. Let's see if we can do that. So if we go to the official README and we see the logo, it should become a little bit more obvious what it means. Look at this. Is it clear?
Oh God. I was waiting for an acronym of some kind, to be honest.
So the idea is that you are consuming the data. So it's like you are eating the data. So I think nom is like the sound that you do when you chew, like nom 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 nom. But this is my interpretation. Let me know if you think otherwise. I don't know if it's saying it here somewhere. Is it?
I have no idea.
Cool. Okay. Do we want to get to some coding and try to implement the Redis protocol?
Yeah. First of all, why are we aiming for Redis in the specific?
Okay, so a little bit of a spoiler. We started doing a coding challenge, let's call it this way, from a website called Codecrafters, I believe, which is basically a website, another website with coding challenges. The one thing that is pretty cool about it is that it's not just a single coding challenge like solve this problem, but it's more what would it take to build a real system or realistic system, something like Redis. I think they have like BitTorrent, they have SQLite, they have oh god, yeah, they have like
Yeah,
actual real software that you might be using every day. And it's pretty interesting because it guides you through the steps. So it's not just build it and that's it and then come back with a result, but it's more a guided approach. And for every step you have tests, you have a little bit of explanation on like what is it that you need to do and why in the context of that project. And right now they are kind of in a beta period, so it is a paid service, but in the beta period you can do the Redis one for free. So we started to look at that, and it's probably something that we will do a little bit more in the following stream. But then we immediately bumped into the problem of, well, Redis has an entire serialization protocol, and you need to deal with that very quickly in the exercise because you need to start receiving and sending messages between the client and the server. So we started to say, okay, this could be a cool example for showing the capabilities of GNOME because the Redis protocol, I think, is really interesting, and we might end up using a bunch of the things we explained. Does that answer the question?
yes. So let's start to part
Okay.
something.
Okay, let me know if this is readable enough. But I want to go through the protocol very quickly. Actually, let's do this for now. This is not useful. Okay, like this. So there are, let's see if there is an example very quickly on, let me just take here. Okay, this is for instance, actually, let me do a step back. The Redis protocol is basically a request and response kind of protocol. So you have a client that sends something, and that something is a request. And as a server, you need to understand what's the request, so parse it, make sense of it, do something, and then return a response. Now, this is probably a silly example, but a request might look like this, or a response might look like this. An error message might look like this. So it's a kind of a readable protocol. It's a clear text protocol. And let's see, another one. This is a structure. Let's see if they have an example. Okay, this is, for instance, an hello message, right?
That is a bulk string. Yeah, there is a first number that say how many bytes the string is made
Mhm.
of.
Exactly. So there is a very specific structure that
The
makes the
star
method.
means that is an array, if I'm not wrong.
There you go. So these are all the different types you can receive. So if you receive a plus as the first character in the message, the first byte, it's a simple string. Then you have simple errors. Then you have integers. Then you have bulk strings. Then you have arrays, nulls, booleans, doubles, big numbers, bulk errors, whatever that means, verbatim string, whatever that
Bulk error
means.
would be the same as a simple error, so that we start with that number of bytes and
Mhm.
message.
Exactly. So we need to, my idea is to write a parser that can give you, let's say, the basic types, because a
Yeah,
message is effectively one of these basic types or a combination of these types, right?
this list
Nested in.
is more than I implemented even when I tried that exercise. So
Mhm.
there are types that I was not aware of. Ah, yeah, because there are some RESP 2 and some are RESP 3. Do
Yeah,
we
and
want to stay in the RESP 2 realm? Probably it's better to start with that.
I think it's relatively easy to implement all of them. It might be more or less time consuming, but I think it's easy to implement a version of the protocol that supports both. They are not
Mm.
like mutually exclusive. It's
Oh no,
more
they're
that
just on
exactly,
top of them.
exactly. So if you want to support older clients, it should be technically possible to have a server that can understand both RESP 3 and RESP 2 without having to negotiate version or switching version, that kind of stuff. So to have kind of a super protocol that
Mhm.
embeds both.
In the chat, they are asking if NOM supports only strings or also works with binaries, with bytes.
That's a very good question. It does work also with stream of bytes. The difference is that rather than when you define your own parsers, the signature, rather than having a string slice, is going to have a slice of bytes. Right? That's your input and the remainder type. There is, I think, an example. I don't remember if it's in the official repository, but somebody parsed some kind of video format entirely with GNOME. So it's literally like parsing raw bytes and building frames of some kind or metadata from the video format. So that could be an interesting example to look at if you want to see how to parse bytes. But in the case of Redis, it's a plain text protocol, so we don't have to think in terms of bytes.
We can parse. I have a library in MicroPython for animated GIF if you want to try to parse them in NOM.
It should be possible. I don't know how complex it is, but it should be possible to do it with none.
Cool. So let's implement this. Do
Okay,
you have
while we do that,
examples?
I'm gonna do a cargo add num. And here, the nice thing is that for every single one of these, we have a few examples, we have a bit of description, we have some edge cases. Like there is a, if I remember correctly, when I first look at this, there are some cases where, for instance, you can have an array of length -1, and that was the old way in the protocol to return a null. So
Oh
you can
God.
also you can also we can also implement and test those particular edge cases because it's I think it's well explained here in this page. Okay,
I
so
like it.
here I just added
Why I like
num.
it so much? Why I like so much the idea that an array of -1 is a null. Something must be wrong in me.
I don't know. Okay, so the next step, what I'm gonna do is, I think one thing we could do is to define a generic enum of values that contains all of them, right? And then we can have a generic parse value, which is gonna return whichever we can parse. So if it starts with a plus, it's gonna return, I don't know, the simple string variant of the enum. So this is gonna be a little bit.
But can have nested objects. I mean, an array can contain
Mhm.
an enum itself. So are we not going back in the problem of stack versus heap allocations and
Uh,
size at compile time?
Not necessarily, because for instance, if you have an array, right? What is it called? Is it called array? Array. Array is gonna be a vec of value, right?
Mhm.
And this is not recursive structure because vec
Ah, because it's a
is
vector.
is implicitly in the heap, right? So
Yeah.
this is just gonna be a reference to something that lives in the
If
heap.
it was an array of value instead, was that a problem?
That would be a problem. So if it was
Okay.
like a, let's call it, and then you have this of value, let's say 4, I don't know, whatever. I think I think this is gonna complain. Yeah, recursive type value.
Okay, got it. Cool. So you
Like you
need to
would need to
allocate.
do something like box if you wanted to do
Yeah,
something like
with
this.
box you can send them to the heap. At that point, is going to work. But
Mhm.
cool. Yes.
But
Okay.
I don't think we are gonna have this problem for this
No,
specific
no.
protocol.
I remember that when we did some advent of code, we landed in that problem.
Mhm.
So I have scars, and they remind me to be
To
watchful.
be careful, yeah.
Yeah, to be careful around those stuff.
Okay, let's start with simple string. Actually, let's say that all the strings we are going to use a string slice. So let's do then simple error. This is going to be a little bit tedious. Hopefully, Copilot is going to help us. Integer, I guess that's good. Bulk string
EC64.
sounds good.
If you want to write for
Array, we have
EC64.
it.
Do you want to stop
Then
here, or do you want to implement also the other ones?
let's read the list. Should be quick. Then Boolean is going to be bool. And then, I mean, we don't have to implement all of them, but we can have the full list here.
Why null is in italic?
Good question. I don't know.
Is some reserved type?
Maybe. I don't think so, though.
Okay, let's go on.
It must be something weird with my VS Code
Let's go on.
language
The
server or whatever.
Rust
Okay.
analyzer will scream at us in case.
Double F64 should be good. Big number. I think here we'll need some kind of library, but for now, let's just use I128 because big number can be arbitrarily big. So generally,
Okay.
they use like a string of digits and then they have
Mhm.
very slow operations, but you can represent arbitrarily big numbers.
So basically
So
Python integers.
oh yeah, because Python does the switch in real time, right?
Yeah, that
Then
Python use the native one until it fit, then it switch to, yeah, please go on, use whatever number you want.
Okay, bulk error. Let's keep a string for now. Verbatim string, it was there.
It was suggesting
Then map. Map, I have no idea if we can use an hash map, maybe.
Probably it's an hash, but why not?
Let's do that. But probably this is going to be a string. For now, let's just make this assumption. We can always change
Yes.
it later. And set is going to be an hash set of value. And pushes,
I have no idea
whatever
what it
that
can be.
means. For now, let's just leave it without any value.
Pushes,
Now,
I have no idea what it can be.
oh yeah, every value needs to be a value of a, which is a bit annoying.
You have to
whatever.
propagate the lifetime.
And then we need to import hash map and hash set. Cool. Now we need to derive here a bunch of stuff. We need to derive EQ and hash, and let's derive copy, probably not, but everything else, yes.
Why we need to derive hash?
Because I think to be able to go here.
No, that is the value. If you want to use it as a
Oh,
key,
but
you
in
need
the hash set, we need.
in the hash set. Okay.
Okay, why is complaining here though? You cannot compare. Is partially equal enough then? Probably this.
Yeah, floats in theory, you should never compare with equality floats.
Ah, interesting. Do we need
can't-
partially equal?
Now it's complaining about what for the float? That you can't hash a float.
Wow, interesting. Okay, we'll see when we get there. Let's remove hash for now. And what else?
And now it's complaining that
it needs to have hash, I imagine. Okay,
so
that's
you can't hash float. Makes sense because you can't compare the quality, so you can't hash and then check for equality.
cool. That's an interesting problem that requires some research. For now, let's just do this. And set doesn't contain anything. When we get to parse that, we'll do some research.
Or instead of using a F264, we keep it as a string. You can keep the float as a string.
Could work. Let's do that, and then we.
Every time you have to do math on top of the string of the float, you have to convert. But here we are not doing the math. Here we are just parsing and sending back. Yeah,
exactly.
just make a string.
Also, Tommaso
said the suggestion in the chat.
Sorry,
because we are a little bit out of sync in time with the chat. So basically, we are ahead of time compared to you. So
then let's do this.
Something in the chat can be slow.
Let's do the same also here, and then we can implement for these variants some kind of as float or as big int, whatever. And then the set is going to be hash set of value.
It's possible to if
do
you add the hash up
EQ
there.
and to do hash. And
Do you
now
need also Q?
I thought so, but what does it miss? The trait bound.
Because in this way, create a set of maps. Because you are saying this is a value. A value can be an hash map. At that point, now you're saying you can have a set of values, so you can have a set of hash map. But an hash map, by definition, is not hashable because it's a mutable type.
Right.
Now we are in a recursive definition of.
Or we have this type is not hashable, so you cannot.
Yeah, you can't put that in a set because it itself is not hashable. Probably we need to have value and keep set out of the game. Set is
Okay,
another
let's.
type.
Do we want to keep these two separate?
Yes, for now, yes.
So let's just, because I think this is a little bit beyond the scope of nom. So let's
Yes,
focus on that problem when we get there. So at
yes.
this point, we don't really need hash or equality, but whatever.
But
Let's do
also, we
that.
don't know if in the I don't know from the Redis protocol if you can make a set of hash maps. Probably you can't, but we still have to read what set does.
Mhm. Okay, so at this point, the first thing we want to do is to do a pub fn parse value, let's call it. And this is our, let's say, top level parser, like the most generic, probably the one
Oh
we're going to
God,
expose.
what is writing?
Jesus, calm down. Okay, and this is what is going to return is a value. Now, because we want to use nom, it's not just the value, but it's going to be an I
High
result
result.
of string, which is what we are going to pass as an input, and value, what we are going to return as output. Now, this is a to-do, because we still need to do it. Let me make a little bit more space. We need to import this library. Okay, so now we are ready to implement the first bit. And the first bit is basically,
You start writing the test or you start writing the code?
I want to start to write the code. Basically,
Okay.
what we can do is say input is whatever is going to be left over, and then we can have type char, I guess. And what we can do is we can use this one off, which comes from nom, and we can just pass a list of things that we can expect. And basically, we need to copy everything we see in this column. So plus, minus, column, dollar, asterisk. Is that an underscore?
Right. Yeah, seems an underscore to me.
Comma, parenthesis, then bang,
Percent. Oh yeah, the
equal,
exclamation mark
percent,
equal percent. The
tilde,
tilde
and this guy. Okay, this is
glitter
a little bit
them.
weird. So when you do one off, then you can pass the input and then question mark because it might
Oh,
fail.
fantastic! Your font made the exclamation mark
Yeah, a
equal.
little arrow and a
Oh,
different. Yeah,
yeah. Well, okay. You have fancy
cool.
fonts.
Okay, so now at this point, what we can do is basically do a big match, right? And we can say match on this type char, and we can say if it is a plus, we can do something. If it is a minus, we can do something,
We do a
and
default
so on.
that does nothing. Or panic. Panic. Should panic if.
Shouldn't be possible because if it's not one of those, it's just gonna fail
Mm.
here. So we can panic just as a. Actually, I think it's even better to use an unreachable. Oh, Copilot is so nice for this kind of stuff. Percent, tilde, and major. And now we have this guy where we can say unreachable, invalid type char. So this code should be unreachable because we should fail here if it doesn't
Why is
work.
complaining of line 33? Oh, no, wasn't complaining anymore. Okay, sorry. It's just
I think it just didn't like this underscore. Okay, so now at this point we can implement one by one sub parsers. So we could say, for instance, here the plus is what? Simple string.
it's the simple string. So there is a
So we
string
could
until
say
the carriage
parse,
return.
parse simple string, and we pass the input. Be aware that now the input is the leftover, so it's not going to contain the plus, but just whatever is left over. So now we can implement this parse simple string. And here at this point, we can even remove the to do. We can just return whatever. And in theory, we could put to dos here, I guess. Okay, so now let's do the parse simple string. And this function can be private. We don't need to expose it. Ooh, we already did stuff. Now let's see if it's good. But
Yeah,
basically,
let's look at the documentation of Redis. what it
W-
defines as a simple string.
Exactly. But basically, the idea is a value, but it needs to be a value of simple string. In the middle, there needs to be some parsing that we're going to check if it's correct. So simple strings are encoded as a plus, which we already matched, character followed by a string. Let's make this a little bit smaller, hopefully still readable. The string mustn't contain CR, so or LF, so /n, and it's terminated by a CR or F.
Okay,
CRLF, sorry.
so we need to wait for carriage return line feed until until those.
And if we want to be super accurate, we also need to make sure that there is no slash or /n in between.
Yeah, but if we find the /r/n, basically we end.
No, because they need to be together to end.
Okay, so you want to say that they should not be before those two. Okay.
We can create some tests, but basically, if you have OK, if in between O and K you have a
Yeah,
/n,
a /r, it
or
should fail.
it should fail. Exactly.
Okay.
So now this is almost good. There is this take until, but I think we can do it slightly different. Maybe one thing we can start to do, because I think we will need this a few times, is implement a CL or F, which, yeah, basically does this. And tag, we can import it. Nom complete, I think this one should do. So when we have this one, what can we
So
do?
you want to take bytes because you say that you want to check for /r and /n. You
Yeah,
want
so
to
there is a
take
take
bytes.
while. So there is a
You
take while.
Yeah, you want to take while is not that. So
Exactly. And we can do stop there. Copilot. Almost good, but not too good. We can do this, or sorry, and C different from /n as well.
okay,
So this is gonna give us
the string and the
the
leftover.
string and the leftover.
The
So if we
leftover
do
should
let
be
input and value,
our string that we need to return. The leftover should be /n. If the leftover is not /r/n, it means that is wrong.
exactly. And there is another one that is called terminated, I think. Input value again, that is called, I think, terminated. Okay, that checks that you parse some value, but whatever value you parse needs to be terminated by the other one. So what we can do is basically take all of this,
So
put it
for
in
the
the
take
first spot,
while, okay,
and then in the second spot we use CR all F. And now we
and we
pass
need
the
to pass
input
input and the question mark.
and the question mark, and we can remove the previous line. At this point, we have the string, and we can just say value. And that should do. Why
Why is
didn't like
complaining about CRLF?
function with sim? Oh, I did a typo. C or
Okay, yeah.
left.
Carriage return line feed.
Okay, let me make this one a little bit bigger. Cool. Now we can write some tests, right?
Yeah, for example, that plus okay.
So let's do the first test, and let's say parse symbol string. So here they say plus okay this. We cannot use parse simple string because it doesn't have the okay. We just need to use the parse value,
Yeah, because it's not handling the plus. Yes.
and it needs to be a value simple string with okay. So it needs to strip the or
And
and the n.
and if we write another test with /r in the middle, it should error.
Mm-hmm. So let's try that. Okay, this one passed. So happy times. And then let's do another one. Let's do parse value of plus o slash n k slash or slash n, and we want to assert
This one is an error.
that this is error. Let's see if that's true. Cool, that works as well.
Nice.
So similarly, we can write, let's see if there is any other edge case. I don't think so.
No.
To send binary strings, use the bulk strings instead, which we can get into later. Okay, simple errors is the next one. So let's do
I think it's
fn
almost the same, probably.
parse simple error. So let's see what it looks like. Yeah, let's ignore this one for now. So what is it saying here? Sorry, let's expand this one. So a simple error is simply just errors are similar to the simple strings, but their first character is the minus m. The difference between simple strings and errors is that you should treat errors as an exception. So it's more of a semantic thing rather than a syntactic one. So it's
Yeah.
going to be minus error message. And they can also have kind of a label, but I don't think we care about parsing the label. We can just keep everything as a single string. Yeah, the first uppercase word after the minus up to the first space or new line represents the kind of error returned. This word is called an error prefix. Note that the error prefix is a convention used by Redis rather than part of the protocol. Okay, so we don't want to bother with
Yeah. We
extrapolating
just
this.
take a string and we go with that.
So what we can do here is literally just say, actually, what we can do is split this one, parse simple string row, and we basically do pretty much that.
We do the cast
Pretty
to
much,
the type later.
we just return exactly. We return everything that we have in there without the question mark, I believe. I think if we do this, then here what we can do is just say
Why without the question mark? It's not. We are not fine with it giving an exception.
because if it's an error, it's gonna just bubble it up automatically. So it's already
Mhm.
returning this structure here.
Okay.
And now here what we can do is just call parse simple string row, get the input, the question mark, and now we already have the value there. And this is going to be literally the same. It's just going to use a simple error instead.
Tommaso was saying there are other characters after slash r slash n, not in those examples. The
Good
string is not
question.
terminated, doesn't seems to be zero terminated. Okay, I think we're fine. So parse error is calling this the raw one and passing back a simple error. Why? Because we are not using it as complaining.
Exactly, yeah. And we pass the input.
As error case, Tommaso was saying, as an error case in the test, can you add also an assert that if it is plus OK slash r slash n and then there
Oh,
is
yeah.
something else?
Good point. Because that
There is an
one.
AOF in NOM to say the reminder should be empty.
Mhm. We can do that at this level, I think. Because I guess if we have, so what we want to be terminated is the entire input, not the sub parsers,
Yeah,
right?
yes. So we
So
should
what we
assign
could
that
do is
this
something like terminated this. That should do it. Is it
there is
called
not a
terminated or
AOF.
complete?
It was not end of file, like
complete. So this one is gonna make
I
sure
see.
that there is no reminder in the string. AOF is gonna make sure that actually maybe it's the same stuff.
Can't you put complete around the match so we don't have to write it everywhere?
No, because you need to change the parser, so you need to do this. We could probably
But you can put the
okay,
complete around
we
the
could do
match.
this. We could do this. Let parser. That's a good point. And
Don't
we
pass
can
the
return
input.
just the parser, yeah,
Yeah, don't
without the
pass the
input.
input, and then we return complete parser input.
And then we return here
Complete
complete parser
parser input.
of input.
Okay, at this point we can.
That should work, except parse error because it's parse simple error, right?
Mhm.
Is it?
Yeah. And now we can implement the test that Tommaso was suggesting.
So we can implement, let's do it here, that if we have assert of okay slash r slash n, and then this should not be here, this one will fail, right?
Should.
What did we do wrong? Expected a semicolon here, yes, fair enough, because we are not returning that anymore. And did it fail? Is not an error. Interesting. Why?
So complete, it's not completing. Try to look at the NOM documentation.
Let me do one quick thing. If we do this, right? We do let, yeah, all of that, and we do an unwrap. And then we print, or we do a dbg of input and value. What do we get? We did get the remainder. This should not be here, is there? So the complete is not working as we thought.
Try to look in the documentation for a function called EOF.
Transforming complete into error. Okay, there is an EOF, so let's look at that one. Where is my browser? EOF, combinator EOF. Returns its input if it's at the end of the input data. Okay, let's do this example. So a parser of empty is okay. A parser of ABC is going to be an error. So yeah, we can probably use EOF, but it needs to be following. So I thought that complete was doing this kind of magic wrapping where it will check that at the end you have an EOF. With this one, we need to be explicit
So
and say
you can do a
combinator.
sequence. You can do a tuple. Your parser and EOF is a tuple.
Yes, we could do that, but I thought that complete was doing all of that for us. That's why I prefer to use that one. So let's understand what this one is doing instead. So this one is saying the parser is a complete of take 5, which means it takes what, 5 characters. So here is taking FG is the remainder, and this one, so no, complete
Was able
doesn't
to
do
take.
what
No,
I
doesn't do
thought.
what you say. No,
So it's the
because
opposite.
it's just giving exception if the parser inside was not able to take
as
something
much
all
as much
as
as you
much as it
expect.
was expecting. But
Okay.
in our case, it was enough. We can do
Is
a
there
tuple
a
of our parser with.
terminated? Gets an
It's
object from the
terminated by an OF in the end. Is a terminated of our parser, comma EOF.
Mhm.
No?
Okay. Okay, let's do that. Let's do a terminated with UF. Yeah, that should be
Tommaso was
one.
asking what terminators is doing, but we just showed it. So
So terminated is basically checking that if you have two parsers, whatever you parse from the first one is terminated by the second one. Excuse me.
so now let's try a terminated UF.
So for instance, here it's saying that tag ABC,
Is then
tag
followed by
EFG means that it's going to try to match ABC, and then after ABC there needs to be EFG.
it consume it, and so it give you back the reminder that is
Mhm.
HIJ, and yeah,
Okay, so here what you're saying is terminated of parser and then
comma
EOF.
UF, and let's see, no, without input because it's putting
So
them together.
EOF, did we import it? We did. We don't need complete anymore. And now let's see if here at this point we should get, I think this should fail entirely. So let's see if that's the case. If it failed in line 80, we are good. Result unwrap of
80.
an error. Yeah.
Yeah, because
Code EOF. Okay. So now we should be able to restore this one and remove this one. But this is a very good suggestion from Tommaso to cover this edge case.
yeah, very good suggestion, and I like the use of terminated with UF.
Okay, let's do test with
An error,
append
yeah.
test parse simple error if I can type. So what do we have? That's, I like the first one.
I just copy and pasted what we've wrote.
So the first one matches this one, but I also want to test this one. So I'm just gonna copy paste 2 times, and this one copy in here. I think here still you have a slash or and slash n that they didn't
Yes,
put in the docs. Oh, come on. And in this case, this is what you should get without the minus and without the new line. And this one as well, wrong type.
now you want also the third one, okay.
Okay. And then finally we
You have to
can.
remove the dash from the assertion in line 95.
Oh, yeah, good point.
And the slash n in the end, I can't see if it's there because.
It is here, but it shouldn't be here.
Okay, yeah, but I was not able to see that. It was outside of the window.
Too much stuff. Yeah. Okay, here error message. This should fail because there is a slash n in between. And this one should fail because there is more stuff at the end.
There are
Okay,
leftovers.
cool. Let's see if this works. Woohoo, works. Okay, so let's see if we can get to do something a bit more complicated.
Yeah, we have some time left. We could try an array or a bulk string.
Let's do the integer very quickly because it should be simple, and then we can get to the bulk string. Parse integer. Now we need to do parse integer.
Let's go into the documentation of Redis and see which kind of integers are those. 64.
Now
Oh,
this is definitely wrong. So let me remove that. To do. Okay, let's check integers. What do we have for integers? Okay, integers has either a plus or a minus, and that's optional. What are these angular braces? I have no idea.
I
The
think.
column as the first byte, an optional plus or minus. So this is just to delimitate the range of characters you can have, I guess.
Okay, base
One or
10,
more decimal.
64 digits, bit.
Base 10, 64 bits. Okay, perfect. So I think there is an i64 combinator. So if we go here, if we search for i64,
Theory, we
I
should
think we
just
can
use
use
that one.
this one.
Yeah, without writing anything.
Will parse a number in text format, can parse until the end of the input. Cool. So let's import this guy. Because every time I try to autocomplete with i64, it doesn't work. So I'm just going to be explicit. Actually, we can wrap it here. Ooh, dot delete. Okay, and here what we can do is basically just say let input value, and it's basically just an i64 of input, right?
Yes.
And here is,
Why is
why does it like
complaining?
that? Okay, no,
Okay, no,
it's happy.
just
Let's see if there are some examples. For example, 0 slash or slash n and 1000 are integer replies of 0 and 1000 respectively. Cool. Many Redis commands return response integers, including increment, len, and last save. Okay, so these are our examples that we can implement. Test, fn, test, parse, integer. Oh, look at that. Column 1000, column minus 1000. Okay.
he's copy and pasting our test, but it's fine because I mean it's less work for us.
Should be reliable test, but it did fail. Where did it fail?
But they failed. Perfect.
Which line? Which line is that? Line 113. 113, it didn't like the first one. So column 1000, it didn't match value integer 1000. What did it match? What happened? Did it unwrap failure? It was an error.
Are we parsing CRLF? No, we are not consuming CRLF in our
Oh,
task
right.
for
Yes, you're right.
because
We
for
didn't.
the basic string we are parsing it if you go above
Good point. I forgot to do this. We could have said terminated and
by
then
CRLF
CRLF, and
because
now
we
it
use
should work.
we use the terminated in line 59 to do that. We have to write
Terminated.
terminated. It's tea time. No, it's a little bit late for tea time.
Okay. Now it's working.
Okay.
Cool.
Now we are consuming the CRLF and the UF is then happy.
Let's try to do the bulk string, which I think is a bit more interesting, and then we can probably call it a day. But meanwhile, if you have questions, feel free to
So
throw them
bulk
in the chat.
string can be 512 megabyte, but I will not check that. I can we allocate.
Oh, yeah. That's a good one. Let's see if it makes sense to check it or not. So bulk string is the dollar one, right? So parse bulk string.
We should find a number, a carriage return, then number bytes, and then another carriage return plus line feed.
Okay, so the first thing that we want to read, we know we already matched the dollar. So we want to get this length here, right?
Yes, that is a number. So
Can it be negative? Let's
no, a
see here.
length can't be negative. Come on. If it's not used for any
Null,
other,
null bulk strings. There you go. It can be negative.
Ah. Perfect. Okay, an E64. Those
Okay, look at that.
512.
Already knows. Copilot already knows. Excuse me. Okay, so let's do let input length, and we can do just I64.
But in theory, it's fitting an I32 if it's 512 megabyte, but okay.
Good point. We also have I32, so why not? Let's do I32, and let's do I32.
In theory, here we could make a check that it should not be greater than
Okay.
the
Now
value.
what we can do is two things. We can do match length, and we can say if it's -1 is null. If it's positive, can you do a match with a guard? I don't remember the syntax. Let's see if I have it somewhere.
Well, if it is everything else, it should be.
Okay, let's use an if statement. So let's if length equal -1, then we return okay null. But it still needs to match everything else, right? Still needs to match
It
slash.
still needs to be it still need to be terminated by /r/n. So you can
So
write in
we
line
still need to
78.
do exactly. We still need to do let input. Ah, I cannot
Tommaso
type.
was asking if it is correct to return a variant that is not a bulk string from the bulk string function. It's possible because you return a value and not a bulk string strictly.
And here, I think what
But
it's saying is that you need to consider it as a null. So I think it's semantically correct.
yeah, because it's a limitation of the protocol. Version 2.
Like,
Now version 4 has the real nulls. But yes, version 2 was like this.
mhm. Yeah. So here is basically saying, for example, a Ruby library should return a nil, while a C library should return a null if this -1 happens. So I
Instead of
think
doing
we are
what you did,
implementing it correct.
instead of doing line
Mhm.
to 80, can you do a terminated E32, comma CRLF in line 78?
But then if there is stuff we need to read, we are not reading it.
No, we are
Like
just
if it's not
consuming them.
-1, but
Yeah,
if
but
it's
there
like
are the reminder will give you other stuff.
oh yeah, but you need to do.
Terminated is not asserting that there is nothing else after it. It's giving you input back.
But I think terminated checks that what you got is gotten, and then whatever follows is terminated, which we don't know.
I think it doesn't work like that from the example you showed before.
Let's review. Terminated.
Because if you look at the second line of this example, the one with delays from
This
A
one.
to J, yeah, the second assertion. If you look
This
at the
one.
second assertion, you are passing from A to J, and you say that you want ABC followed by EFG, but the leftover is HIJ. That is exactly what we want. We want a number followed by a carriage return line feed, and then we take what is left and we go on from there.
Oh, I see what you mean. Because yeah, there needs to be this anyway. Yeah, that makes sense. Okay, I get your point now. I was thinking more in this case, but in this case, you have slash or slash n
Yeah,
anyway.
anyway, and
Cool.
then we have to start taking
Yeah,
the.
I don't know why I assumed that if it was 0 or -1, you wouldn't have these two in between.
No, you have it. Was it
So
accepted?
that's good. Okay, good point then. Then we can do terminated. of this and CL or F. So we got rid of that one. What's going on?
Sierra left again. York
Again,
is left
yeah.
here.
I think I'm getting tired. Okay, so we need
You have
to
to remove
also.
line 80. Yeah. Get a remove line 80.
All right, because in -1 we don't have it, but if it was 0, we had it. Cool. So we
But
can
if it
remove
was
this
0,
one.
now we read 0 bytes if
Yeah,
it was
perfect.
0.
Okay, so this one makes sense. Now the other case is if it's minus lower than -1, that's a
Is an
problem.
error.
So if length. Now, how do we return an error? That's where nom gets a little bit tricky.
Oh, mamma mia.
Hmm.
What is that? An error of a non error, of a new error, of an input with an error verified.
Right. Should we trust Copilot that this
But
is what?
let's go on. Error kind, is this a verify? What are the error kinds?
Good question. I have no idea what verify is. Let's search in the docs.
So this is a
Verify. So these are all the possible errors that are kind of built in. Which parser return an error? Right. I wonder if there is a way to do
custom error.
mhm. I think I
Let me
did something like this in the past.
Yeah, but let's leave verify for now. I mean, let's throw a built-in error, then we see.
Oh yeah, I see where it is. Okay. I have it in an example. So where somewhere else I had like a list of all the stuff I
Mm.
did with nom in the past.
That's the
So
cheat
what
sheet.
we exactly what we can do here is fn, and we can do I32. Um, let's say, what do we say? Or -1. Actually, we can do U32 or -1, something like that. And this is gonna take an input string and is gonna
So
return.
this is another non-parser, basically.
Yeah, it's basically for our own convenience, right? So what we do here is there is a verify feature. I think that's why there was that suggestion. So let input value. Here we do, I think it's called just verify. And then the parser is the first one. So I32. And then we have the value here. And we can say that V needs to be bigger or equal than -1.
This one is going to consume the input or not in reality?
It is, yeah. It's still gonna consume the input and then we return this. But it's gonna make sure that it matches this condition, otherwise it's gonna throw an error.
Mm.
Now, what am I doing wrong? Is this the right syntax? No, that's the right syntax. Verify needs to be imported. Why doesn't like -1? Oh, consider borrowing. Because I don't know why.
To know
Okay,
why it's checking, to not consume the value, but to not get ownership.
now we can do this. Rather than just I32, we can do this. And now we
Okay,
are sure we don't need to handle this case.
nice.
So the remainder case is that we need to read this
And
many
we need to
characters.
read length bytes.
Exactly. So how do we read n bytes? I think there is a take with a
Take
number.
file, take.
So input value, and we can just do take, and I think it length as you size. So we can pass
We
length.
need to do a terminated take,
Mhm.
comma EOF, no, comma CRLF.
And now input blah blah blah. And at this point, we should be able to return that.
I think this covers also the zero case, but we are going to write a test anyway for that zero. I think this covers it.
This guy. Is this going to work? Let's see. Let's do a
We have
test.
to write the tests, or Copilot has to write those tests for us.
Parse bulk string. And probably if we complete this exercise, there is a bulk error as well. So we might have to do the same raw version. But for now, let's not care.
Next time,
Okay.
probably.
Let's copy these examples. I like this one. So for this one, what we need to do is assert equal of parse value of all of this. What do we expect? We expect an OK with nothing left and the value bulk string hello, right?
Yeah, also because if there is something else, it should just throw.
Let's see if that's true. Ooh, it's working. Nice. Then let's try the zero case. So if we copy all of this and we do here at 0 and then or n, this one should be empty. Cool, it's working. Now let's do the null case. So if we do -1 and we don't have slash or slash n, and this should be value null. Very good. So this is still working. And now we can throw in a bunch of weird cases
But you can
like
put a -2,
-2, right?
yeah, to
So
see what is
we can
the
say
error.
assert that -2 of whatever is error. Let's see if it's true. It is. Good. And then another error could be that you read
Try to do a string of I don't know,
like
10,
5,
10,
but you have
10.
only 3. Okay, 10,
No,
and you have only a law, right?
yes, and yes, you have less. Then I had another idea. This is an
1, 2,
error, I
3, 4,
think.
5, right? So this should
This
be an
should be
error.
an error. Yes. Okay.
Yeah, it is an error.
And then try 10, but then you do something that is correct because so copy the first test.
Mhm.
This is not an error test. This is a correct test.
Oh, okay. So let's do it here.
Put a 10 instead of a 5.
Uh-huh.
Then you write hello slash r slash n that are another 2 bytes. So
Yes.
we have 3 left, 1, 2, 3.
Hello foo.
Yeah, and slash r slash n at the end.
Slash r slash n foo.
No, after the foo.
Oh
You
yeah,
need slash
this
r
one as
slash
well.
n also after the foo. Yeah. But you don't need them below. So in theory, these should be correct.
That's a
Because if
very
you
good
want to do
test,
strings with slash r slash n, you have to use bulk strings.
and it works. Cool. Okay, so should we call it here or
Yeah, I think for this is a 1 hour and a
maybe
half.
just something quickly that we can show, mention, not even show the code, but the idea is that if you have an array, this could be the interesting one. Basically, you can call recursively the parse value.
Do you want to show this next time? Do you want to do that
I
now?
think we can show it next time, but think about that, right? As we are building these parsers, there are also combinators in NOM where you can repeat another parser multiple times. So basically what we will be doing here for an array is read the size and then repeat the parse value n times. And then you get a
Yeah, because
vector of value
because if you
return.
show the documentation for the array, just briefly to explain.
It's an asterisk, number of elements, and then elements
Yeah.
that you need to parse again. So for instance, here we have asterisk 2, and then the first element is dollar, and dollar was a bulk string. right?
Yes.
So you need to call the same parse value again multiple times.
In that case, the string will not end. So we have an AOF, but the array is going in EOF. But the single value inside the array is fine to have leftovers. So the array itself should not have anything after it. So EOF is fine.
Mhm.
But a single subparser
Right. We might have to split the
can
parse
have,
value with a parse complete and a parse
yeah, parse,
whatever.
the main level parse and the sub,
Yeah.
yes, but we have to split
Or
it.
a parse row and whatever. Yeah.
Mhm.
Okay. So let's wrap it up.
So let's wrap it up. You can find the recording on YouTube. The link is in the Twitch in the About session. If you are watching this on YouTube, we do live streaming on Twitch every Monday, 6 p.m. Dublin time. Make sure to check the Twitch link in the YouTube description and give us a follow and tell that you love us. Feel free to leave us comments and open PRs. Are we going to put this in any GitHub repo? Probably yes.
Yeah, I'll probably start a new repo.
Perfect. Everything is well accepted. We are trying to learn Rust, so don't expect our solution to be the best one. If you know something better, please tell us. Thank you for all the collaboration in chat down there. So,
Enjoy.
bye. See you next time.
Bye, everyone.